Welcome to the Composition of Mixtures video. By the end of this video, you should be able to explain what a mixture is and be able to use elemental analysis data to determine the composition of a mixture. So looking again at our organization of matter chart, we've now moved on to this side, right? So we're no longer interested in pure substances, we're now looking at mixtures. Mixtures are a physical combination of two or more pure substances. So notice in these two examples here we've got an element, which is a pure substance, mixed with a molecule, which is a pure substance, but they are physically combined, not chemically combined. They're not bonded together. Again, here we have one molecular compound and a different molecular compound, and they are physically mixed, not chemically combined. There's two types, homogeneous and heterogeneous. Homogeneous mixtures have a uniform distribution of the different pure substances, meaning they're basically like evenly distributed, whereas a heterogeneous mixture has an uneven distribution of the different types of particles. The important thing to know about mixtures is that they have no fixed composition. Unlike compounds where the atoms must combine in a particular ratio, the pure substances in a mixture can be combined in any ratio because it's a physical combination. Nothing chemical is happening. So how do you determine the composition of a mixture? We can use elemental analysis data to determine the percent composition of a mixture by mass. For example, imagine you're given a 7-gram mixture of NaCl and AgCl2. Using elemental analysis, we find that 0.1 moles of that mixture is sodium. What percentage of the sample then is NaCl? Well, consider NaCl, right? NaCl looks like this. This is a formula unit of NaCl. Notice that for every one Na, there's one Cl. It's a 1-to-1 ratio. Therefore, if we have 0.1 moles of Na, we also have 0.1 moles of NaCl. Since every NaCl contains one Na, it's a 1-to-1 ratio. So now, if we know that we have 0.1 moles of NaCl, we can convert that to grams by multiplying by NaCl's molar mass, which is 58.44 grams per mole. That gives us 5.84 grams of NaCl, meaning that this mixture contains 5.84 grams of the NaCl. Presumably, the remainder is AgCl. Now, since I was asked about the percent composition by mass, I'm going to take the mass of the part, which in this case is 5.84, divided by the mass of the whole, which in this case is 7 grams, multiply by 100 to convert it to a percentage, and I find that 83.4% of this mixture by mass is NaCl. Here's an example to try on your own. Notice it's a little bit more complicated because I've given you grams to start with rather than moles. Pause the video here and work through this problem. When you come back, I'll reveal the answer. Welcome back. You'll see that I started by converting my mass of calcium to moles of calcium. And now I know that since every one calcium carbonate contains one calcium, I have a 1-to-1 ratio. So if I have 0.0237 moles of calcium, I must also have 0.0237 moles of calcium carbonate. You'll see that I set that up in this step here as a proportion. You can also just kind of do it in your head since you know it's a 1-to-1 ratio. From there, now that I know how many moles of calcium carbonate I have, I've converted it to grams by multiplying by the molar mass. I find that of this 2.75 gram antacid tablet, 2.37 grams of it are calcium carbonate. So like all percentages, I divide the mass of the part by the mass of the whole, multiply by 100, and I get 86.2%. That brings us to the end of this video. Let's review our goals. First, we learned what a mixture is. Recall that it's a physical combination of two or more pure substances. And then we learned how to use elemental analysis data to determine the composition of a mixture.